The James Webb Telescope have undermined the case for the Big Bang.
Telescope, ever launched into space, made another successful step on its journey to a point 1,000,000 miles away from Earth today.
When the James Webb Space Telescope, JWST, turned its powerful infrared eye to a tiny sliver of the night sky and observed what appeared to be structured, rhythmic light pulses 7 trillion miles away, the scientific community stood stunned. These lights, faint yet consistent, were unlike the random glimmers of stars or the chaotic flickers of distant quasars. They resembled something far more familiar to human eyes: city lights beaming out in tight formations in linear bands and circular clusters, their geometry far too ordered to be a cosmic accident. This observation sent ripples not just through the world of astronomy but across all scientific disciplines. Before we start, hit the like and subscribe buttons for more exclusive news. The James Webb Telescope, the most advanced space observatory ever launched, was not designed specifically to detect signs of alien civilizations, but rather to peer into the deep history of the universe, to see the birthplaces of stars and galaxies, to understand the formation of planets, and to study atmospheres of exoplanets for clues to habitability. However, with its unparalleled sensitivity in the infrared spectrum and a resolution far exceeding its predecessors, the telescope exceeded expectations. What it captured in this moment wasn't a sprawling nebula or a swirling galaxy. Instead, it observed a patch of sky containing a pinpoint of light showing patterns remarkably reminiscent of artificial illumination. To comprehend the magnitude of this discovery, it's necessary to understand the scale and distance involved. 7 trillion miles, or roughly 1,100 light-years away, places the source well beyond our solar system, nestled deep within the interstellar medium. At that range, the signals received are immensely faint, having traveled through centuries of cosmic interference, dust clouds, radiation, gravitational lensing. And yet, the JWST managed to isolate the light, map its structure, and confirm its consistent pulsing pattern across multiple observational windows. The structure of the light itself is what initially puzzled astronomers. Natural light sources like stars, novae, or even brown dwarfs emit energy across a spectrum that is either continuous or characterized by absorption and emission lines that correspond to chemical elements. This light, however, broke the mold. It repeated in exact intervals, with pulses matching intervals that strongly resembled a synchronization system, almost like a grid layout. When the data was reconstructed and compared to satellite imagery of Earth's nighttime cityscapes, the similarity was uncanny. There were variations in brightness, patterns that hinted at artificial zoning, and a repetition that defied natural explanations. The discovery opened the floodgates of inquiry. Could this be evidence of an advanced civilization, broadcasting its existence whether intentionally or through the mere byproduct of their urban life? Could this be the first time humanity has caught a glimpse, however indirect, of life beyond Earth that has reached a technological state capable of altering its environment on a massive scale? Scientists began examining the light further. They deconstructed it into thousands of data points, searching for heat signatures, spectral anomalies, and waveforms that might confirm the nature of the source. What they found supported the idea that this was not just light reflected from a star or refracted through cosmic dust. The intensity profiles shifted with a regularity that suggested energy use, energy management on a planetary or perhaps megastructural level. The fluctuations mirrored patterns similar to power consumption curves on Earth. Stronger outputs during what would be presumed daytime hours of a civilization, tapering off and then rising again cyclically. And then came the environmental markers. By analyzing the reflected spectra, astronomers were able to detect trace elements in the exoplanet's atmosphere that included nitrogen dioxide, sulfur dioxide, and even chlorofluorocarbons, compounds not known to be produced in large quantities by natural processes. On Earth, these are typically byproducts of industrial activity. The notion that a planet more than 1,000 light-years away might have an atmosphere influenced by intelligent industrial beings was staggering. It was no longer just light, it was potential pollution. It was evidence of a biosphere, or even a technosphere, actively shaped by its inhabitants. The implications were immense. If this was indeed artificial light emanating from a distant world, then it meant we were no longer alone in our ability to alter a planet's surface in a visible, measurable way. It validated decades of theoretical discussions about the detectability of advanced civilizations. The concept of a Type 1 civilization on the Kardashev scale, a society capable of harnessing the energy of an entire planet, was now being considered not as a distant hypothetical, but as a real possibility manifesting itself through patterns of structured light. This singular observation redefined the goals of astrophysical exploration. It validated the long-standing hypothesis that if intelligent civilizations exist, they may not reach out via radio signals or interstellar probes, but through the simplest and most unavoidable form of leakage, light. And not just any light, but light that bears the fingerprints of planning, control, and perhaps even culture. The patterns observed weren't random. They appeared to suggest intentionality, as though there was some underlying logic or aesthetic behind their formation. Perhaps even a city layout, perhaps even art. For decades, SETI researchers had focused on narrowband radio signals, combing through the static of the universe hoping to find a hello. But this changed the game. The JWST had demonstrated that light itself, in its arrangement and behavior, could carry the evidence of intelligence. It was like catching a glimpse of a distant coastline and seeing the unmistakable grid of street lamps stretching toward a horizon we had never imagined we'd reach. As more data came in, it was confirmed that the source was situated on a planet orbiting a stable sun-like star. The planet lay within the habitable zone, neither too hot nor too cold, and showed signs of having a thick atmosphere. Infrared mapping revealed possible heat islands, areas warmer than the surrounding regions, potentially indicating concentrated energy use. These thermal anomalies matched the light pulses and further strengthened the case that what JWST had observed was the distant echo of civilization. In addition to the visual data, faint electromagnetic emissions were detected in non-random frequencies. Though they didn't contain recognizable information, their consistent presence pointed towards sustained technological processes. There were no decipherable messages, no obvious attempts at contact, just the silent roar of industry, the glowing footprint of intelligent life carving itself into the fabric of its world. Perhaps the most fascinating aspect of the entire event was the temporal consideration. Light from 1,100 light-years away means we are seeing this civilization as it was over a millennium ago. The lights we observed are echoes of a distant past, a frozen moment in another world's history. Whatever culture or species created them may have advanced further since then, or disappeared entirely. But in that single window of light, we had confirmation that we were not the sole architects of artificial brightness in the cosmos. The discovery reframed human understanding of its place in the universe. Philosophers and scientists alike began to ponder the scope of cosmic evolution. If another species had reached a level of development comparable to, or even beyond our own over 1,000 years ago, then life in the universe might not be rare after all. Perhaps intelligence is a cosmic imperative, emerging whenever conditions allow. Perhaps the lights we saw were merely the first of many. The potential cultural implications are vast. For centuries, humanity has stared at the stars, crafting myths and dreams, songs and philosophies based on the mystery of the unknown. The possibility that those dreams now have a factual anchor is not just exciting, it's transformational. This single observation reshaped fields ranging from astrobiology to theology, from planetary science to ethics. Even the way we look at our own cities changed. On Earth, city lights have long been symbols of progress, ambition, and human achievement. Now they are also a form of cosmic language, a universal signal that a species has reached a certain level of complexity. The thought that our own artificial lights might someday be observed by another world as evidence of our existence added a new layer of meaning to what was once just background illumination. The event also fueled speculation about the technological nature of this distant civilization. What sort of energy sources powered those lights? Could they have harnessed fusion? Were they still reliant on combustion? Did they transmit energy wirelessly across continents? The lack of flickering or inconsistency hinted at an advanced, efficient infrastructure. Perhaps their cities floated in the sky. Perhaps their buildings glowed from within with bioengineered luminescence. The possibilities, though speculative, were thrilling in their scope. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us? What are your thoughts on James Webb spotting city lights? Could it prove alien life? We want to hear from you. Thank you for watching and see you next time.